Okay, so this one is for 3.7 paper homework, Math 141, Pre-Calc Part 3. It's optional, but it's helpful. We've had some similar problems in our modeling section, so this is good review. So we have a can on the shape of a right circular cylinder is required to have a volume of 500 cubic centimeters. So again, that's our constraint that we need to work with. The top and bottom, so I have both the top and bottom surface area that I need to consider, and they're circular. So we have pi r squared is our area for circle, and we have two of those. So that's represented right here. You can see my diagram, and they're made of material that costs 3 cents per square centimeter. So we'll have to factor that into our cost function eventually, but let's just kind of lay out what the surface area would look like. And then the sides are made of material that costs 2 cents per square centimeter. So the side, it's a cylinder, but we're just looking at the surface area. So the surface area of a cylinder, if you imagine like a tube that you would cut and then lay flat, you would have your the actual circumference of the tube would then, lay out and be your length, and then you have your height. So that is represented here by 2 pi r, which is our circumference, and we only want to have that one time because we don't, we would just have one length times height for area. However, we're also given the volume here that it's 500 cubic centimeters. So that's where length times width times height on this one, or volume, like we talked about, is pi r squared times the then the height, right? So we're going to need to factor that in and get our height in terms of radius. So let's look at our volume. So see if you can try that one now that you get this set up. I'll write it out. Okay, so just to be clear here, the equivalent for volume for a cylinder, instead of length, times width, you're having the pi r squared, having your area of the circle, and then the height is, kind of all those circles put together. So you have your times h, and then we're going to solve out for h, and we get 500 divided by pi r squared. I'm going to go ahead and sub that in right here for h. Meanwhile, I'm going to look at my cost function, start writing that out. So I know my cost, whoops, just get rid of that other part of the question that I don't need, right? I just moved it down to give us more room. So we have cost of r. So this is the ends here, the 2 pi r squared, and that's 3 cents per square centimeter. So we're going to write 0.03 times the 2 pi r squared, and then we have our 3 cents for the sides. So, 2 cents for our sides. Okay, so that's 0.02, and that'll be times our 2 pi r times height, which we're replacing in our 500 over pi r squared. So now we need to simplify that. So this r will reduce to 1. This will become just a plain r. The pi's reduce out there. What else can I do? I think that's it for there. Then I'm going to multiply. I can multiply anything out on this next line. So go ahead and do that. So our cost function related to radius is going to end up being 0.06 pi r squared plus 20 over r. And we could do a similar thing as we did in question 11 and just kind of combine our terms. We could make a common denominator here if we wanted to, and make it be 0.06 pi r cubed plus 20 all divided by r. But that you can just type in this first one we did here in the purple that could go into Desmos just as easily. So now I'm going to switch over to Desmos and I'll type that in for you. Okay, so I'll show you how to do it. Just typing it in as it read the first way. So 0.06, and then we need pi and r squared. I'm going to use x to represent r so that Desmos recognizes it. And then plus 20 divided by x. Get over there. Okay, so make sure that you arrow out. So if you're down here from on the denominator, get rid of that. You can arrow over to put your parenthesis in. Just pop it up. And now you have your graph. And if we look at our minimum cost, this is kind of, it looks just like a parabola to start with if you're too close together, but see now that you get to zoom out and you can see that it's the rational. So we know it's not a quadratic function, right? So we want to make sure we really zoom in on this one. Okay, so what's our minimum? I'm kind of hover here. It's kind of a little tricky, but what I did, you can see there it's 7.984 for my Y value. That's the C, the cost, and I'm looking for the minimum cost, right? And so that's what I was finding. So when I hovered over here on Desmos, it really, that's what it wants to give. That's what it'll kind of gravitate toward, is the lowest point. You can kind of get the general vicinity, but it's hard to tell, but it will do it for you. You could even just blow it up a little more too, but it does get a little fussy. You can use a graphing calculator. So if we go back to here, I'm going to jot down the answer for that our minimum cost was $7.98. So we're just estimating. The graph is in Desmos, and if we want to think about the domain, I wrote it there so I wouldn't forget. Let's go back and check on that. Okay, so here's the graph again. So you could just get a good spread. I mean, basically you could have anything bigger than 0. And on the graph that's on your key, again, those are just the windows that you use for the, whoever did it for that key. I think it's a graphing calculator, what the values were for the domain and range, like the size of the window. So, you could see here how that kind of matches up to the picture you would have in your answer. So you could pick anything over a reasonable domain. It's really not even asking you to state it, but that's how we want to just kind of set up our window. And if you were submitting this for a test or something like, or a quiz, you can use Desmos for these. You really kind of have to. And you can just take a screenshot of it and put it in there. But I'm going to say, like, maybe we could do 0 up through 15. That's what I want to do. And see how that would work out. Does that make sense? Does it Is there anything that when you go to put it in, does it not make sense? Should you shrink it back down? You can look at those kind of things. All right, so that's it for this video. So I hope that helps you to set up. The key thing I'm looking for in this course is just to get you familiar with this kind of stuff here. The setup, like, can you pick apart, like say you don't remember the surface area formula, can you pick it apart? Can you put the pieces together? Do you know that you have two different things you need to multiply? Can you substitute, given a constraint, can you substitute in, get things in terms of one variable, that kind of stuff. Be able to then use calculus later. You'll be having a leg up on that because you're going to see these again and you're going to use different techniques to solve them out. All right, so have a great day.